I have sort of a sequence that I ask these questions in order for how to price your customer. And I'm going to explain this sort of in the terminology of trains, and then I'm going to sort of show you in the remaining time what I mean by them and how to use them and a few sort of case stories on this. So the first level is that you have a capability. So, and I'm deliberately actually not saying a technology, because the capability is the technology plus all the, let's say, service that you can wrap around it. Let's say that your capability is that you've invented the railroad, you can take people from A to B. Now, the first step that you should do is actually not the ticketing structure. Actually, you need to go one step higher first and then say, are we even serving just one market, or are we serving several markets with this capability or technology? And for trains, actually, you're serving at least two: passengers and freight. You can't create the same pricing and packaging for passengers and freight. They're two distinctly different things. Different customers, different pricing model, even to some extent some different technology that you need to apply in order to actually serve these two markets, even though it all rides on the same underlying rails that you built. Okay, I'll show you a few examples on this in the coming slides. The next step is the packaging. This is where you have ticket classes for passengers, and for freight you might have goods types like bulk, dangerous goods, perishables, and so on. Add-ons come aside there. Then comes pricing model. So for passengers, it's something like, well, you have a price per mile driven, maybe differentiated across the ticket classes. Maybe you have a reservation fee or something like that. Over in freight, it might be per tonnage or per cubic foot, but also per miles driven. So the way that you price and monetize the different markets is different based on the packaging that you set in place for them and then on the pricing model. If you have all of these things down and you have a relatively good idea of the fencing, of the packaging, and the pricing model, my argument is that you are now 80 to 90% done with your pricing. So the last step, the price points, are actually sort of an afterthought that comes once you have built all of these things. And also, they're much easier to calibrate and much easier to get right if you have a good sense of the packaging and the pricing model and the underlying markets that you're serving. Okay. I'm going to show you what fencing is, how to use it, what packaging is, how to use it, and how, at least to begin with, I start building some pricing models. So, fencing. The core design concept of fencing is, we see if we have different markets. If we have different markets, freight and passengers, we simply create different packaging and pricing for each market. So the characteristics are that it must be clearly definable by both you and your customers. So an example that isn't a good fence is small and large customers, or enterprise and non-enterprise, because it's not clearly definable. It's sort of a judgment. Another that isn't very good is geography. Geography can very clearly, at least for some products, be kind of fluid. So exactly where our business is based today, if they serve global markets, and so on and so forth. So usually that's not a very good fencing either. So for the same reason, because they are clearly definable, also they're quite often unjumpable. So let's say I'm a good fence sometimes are sectors, so public, civic, private. Sometimes a fence I use is on-prem versus cloud-based, or your cloud versus our cloud. Can also be sort of really good fences. They're technically jumpable, but they almost never are jumped. So let's do that. So it should also, another good rule of thumb for fences is that it should in most cases be seen as fair enough to be publicly available. Like, it's not a problem for either the passengers or the freight buyers that you have both kinds. They even prefer it, right? And lastly, the rule of thumb is it should be worth it. For you to set a fence in place, I'll show you a few examples in the next slide, everything should feel easier, not harder, after you set it in place. So I'm working with a health tech startup right now. They are serving doctors' practices, and we have decided to fence their product into primary care providers and specialty care providers. That makes a lot of sense to that market. It's clearly definable by everyone. It's even in the doctor's license. It's unjumpable in 99.9% of cases. It's seen as fair to be publicly available. And by separating their product into primary care and specialist care, they're actually able to much better package and price each of these sort of underlying markets that they have. So I'm going to give you another few examples here. So this is a piece of software that provides, it's called PeerGrade. They give professors and universities a platform where their students can grade each other's papers. So it increases learning, it decreases churn, it decreases time spent by professors, so they can actually, good professors can run more classes, they save on teachers' assistants and so on. They have fences in place here where they treat instructors, so that's professors, and institutions and corporates way different. So you're not selling the same product with the same pricing model to an individual professor as you are to a university, and so on and so forth. Another example is, this is a mock-up from a workshop where we were trying to create an packaging for an AI platform that was targeted financial institutions. And up at the very top, you see that we are fencing it banks versus insurance companies. I agree that sometimes banks are insurance companies and vice versa, but the way that this provider was going to the market, it was very clearly separable. It makes a lot of sense to them. They had a lot of pre-made models, AI models and machine learning models that worked in each of these sectors that they could then put into each of these. That made a lot of sense. So fencing simply is sort of what sits at the top of your pricing page, often is what I call it, where people quickly can identify themselves. What am I? Am I a bank or insurance company? Then I'll click that, and then I'll see what you have for me. And I'll ignore the other part, knowing that it's not even an option that I can buy. So, packaging. So this is where we go from passenger trains and freight trains down to, so first, second, third class tickets, or perishable goods versus dangerous goods, and so on. And packaging is sort of the tricky part, and often actually where I, with my clients, spend a lot of time. And I'll give you an example for a client that I worked with a year and a half ago. So they're a German logistics OEM. They create different facilities for logistics providers such as airports, warehouses, and so on and so forth. And they had invented this data analytics product that was to be put on top of the installations that they sold. And they had a very dedicated and team that understood the vertical that they were in very, very well. And they were able to provide a lot of value with this data analytics software product that they were pushing out. And also they had these ideas for where to take this product over time. So they had a roadmap for it. So essentially they said, well, from a technical perspective, what happens first is that we take all the data out of the machines and show it to the customer. So that is sort of the describe phase. We're saying, okay, so this is all the data. And then the next thing we do is that we tell them what the data means. So we diagnose the data. We say, well, the reason that you're seeing all these fluctuations is because these parts of your facility isn't running very well, or whatever is happening. Okay. You have a bottleneck, something like that. And then they said, the next step is that our machine learning algorithms actually pick up on this interplay between describe and diagnose, and then they're able to predict. So they'll say, well, if you process 100,000 of these packages every day, and you do it with this much staff, and your third production line is down, then surely you'll get a bottleneck and you'll be this much delays. So they get to predict. So they say, well, you're approaching an unwanted scenario, so do something about it. And then the fourth step is actually, oh, and here's what we suggest you should do about it. So maybe you should improve capacity over here. Maybe you should actually sort of slow down this line so as to maybe make everything go slower, but without grinding everything to a halt, and so on and so forth. So the technology was sort of built up, so the packaging was built up around the progression of the technology. And I think many people that have worked with different sort of machine learning technology will sort of recognize this kind of track, tech track that they put out. The problem was that when they had taken it to the customers, and they had a lot of customers already, so they were essentially just trying to upsell existing customers, they encountered a world that looked something like this. So they had the 4 different packages, and they went to the organizations that they were selling to, and the organization said, well, we have 3 or so different use cases that we could push this in. We have maintenance, operations, and then management. And the use cases are quite distinctly different. So maintenance, they want predictive maintenance. So they want to know when machines break down and when we should repair them. Operations, they might want something else, and management might want something decidedly different, like prescribe or something. So because each of these silos in their customer's organization didn't want the same out of their product, they had considered just splitting it up and say, well, each of the silos get to choose whatever they want, right? And even for some cases, they would say, well, some even have Describe because of some other software, so they just want to buy Diagnose, they don't want to buy the first bit, and so on and so forth. So the problem with this was that because they had a few add-ons as well, we could see that the number of different combinations of potential product that they were pushing into the market actually exceeded the number of potential customers. So the complexity was way too high, and essentially the sales force was having a lot of difficulty describing the product as a tool instead of having predetermined what jobs the product could actually solve for the customer. So the suggestion that we essentially ended up with was something like this, saying, well, you should just package alongside the silos. Each silo presumably has a very clear understanding of their world and what they want to do, and then you just get to do it better and better as your technology roadmap actually evolves. So we created packaging something like this. So what we see is that often when we do packaging, we have this tendency to say, well, we're going to create 3 packages, like a basic and an advanced and an enterprise, or gold, silver, bronze. You know the kind. And there is this tendency to say, well, all of the things we can do, all the best features are in the gold package, and then, silver is lacking some of the more advanced ones, and then the bronze one is almost unusable. So we call this a good, better, best model, where we're saying we have one problem, and if you want to have it solved fully, you buy the best package. If you want to have it solved only to a medium extent, you buy the middle one, and so on and so forth. I think that is a wrong approach, and I meet it all the time, and I meet teams that have issues with it all the time. I think a much better approach is to say, what job are we solving for the customer? If we can identify that, then let's push all our resources, all our technology, all our services in on solving that job. One job, one package. Once we have solved that, we can identify another job that we can solve. And then that other job gets another package that we can solve. And then we can have another conversation around how to sequence them and stack them on top of each other. But the underlying idea is, don't package according to your technology, package according to the jobs. The definition of a job is a problem that is being chased by money. So it's not just a problem. It is a problem that a customer is actively looking to solve. So they have budget for it, and they are realizing they have this problem. They're already sort of spending these, let's say, resources, both in terms of time and money on it. The concept isn't mine. It's Clayton Christensen's, the late Clayton Christensen. He died 2 years ago, Howard Business School professor, also the father of the disruption concept. He wrote a book called Competing Against Luck that will give you the highlights of working with jobs. I highly recommend it in a software as a service context. So, pricing. So now we have the fencing in place, and now we have the packaging in place. Now it's time to actually figure out how we price these things. It should already be easier. You should already have this idea that you have sorted your markets and you've sorted your customers into different jobs that they are going to have solved, which makes it much easier to price for you. But a pricing metric, let's just go over that first, is this idea that it's any price per something. Price per gigabyte, price per user, etc. And I showed you the overall pricing architecture slide at the beginning, where the pricing metrics are the one that sort of expand over time as opposed to flat fees and everything else. And if you get one thing right in your pricing architecture, it's to get your primary pricing metric right. Never price a software as a service business only with flat fees. Don't do it. Always have some price per core, price per you invented, but make it a price per, because it allows you to price less for customers that don't use as much, and price more for customers that use a lot or get a lot of value out of it. Good pricing metrics are, or have a few sort of characteristics. I want to go through them with you now. So the first one that we should mention is that it should be measurable and executable. So if you're pricing per API call, you should be able to measure the API calls, and you should be able to do it in a timely manner where you can push it into an invoice and actually get it to the customer and they get to audit it, and so on and so forth. If you can't measure it well and you can't execute it well, or with some sort of instability, it's probably not a good pricing metric for you, and you should sort of default to something that you can measure and execute. And then I've written two things here as well: value chain position and expectation to pay. And I want to show you what I mean by those. But let's look at it through the lens of a case here. So this is a company, a Danish spin-off from a large sort of fintech that I work with, 2021 AI. They built an AI platform for banks, and the platform is called Grace, and you can buy a license to Grace. And the way that they've priced that is using two pricing metrics. One is number of models in production. So the more models you have in production on the Grace platform, the more you pay. And the second pricing metric is users. So the more users you have that have access to the Grace platform to produce these models, the more you pay. So they have a little matrix where if I have, let's say, 10 users and 10 models, then we look at the price, which is 12,500 euros every month. All right, perfect. So when I look at a case like this, I ask a couple of questions. So first in is the pricing metric actually representing value? So is it more of this metric, more value? Question mark. And when you ask this of models in production, then the answer is pretty clear. So the 2021 said, yes, well, models in production is why customers come to us. They want more AI models. So that's what we sell them, no problem. They have no problem paying more the more models they get. What about users? Do your customers actually want to buy more users? No. They had never sold more than 8 users to any customer in the first go. Because customers had the sense of, well, how many do I need to run this platform? And then 2021 would do this song and dance, say, well, the more users you have, the more value you'll get, and so on and so forth. But their banking customers would be conservative and say, well, we're just starting up with this AI thing, so let's start with 8. So to counteract that, they started to sort of move these included components out on the right-hand side, where say, well, if you want Spark, then damn it, you're an enterprise and you have to pay more. Which created this sort of dilemma where some customers who wanted that feature but only had 5 users felt that they were, by definition, overpaying for something, which showed itself in the discounts they were giving. So when we walked through their sales, we could see that a lot of discounts were given because customers sort of felt that they weren't consuming the amount of product or features or users that was implicitly available to them in the plan that they were paying for. So maybe that makes sense to you, but I want to point to an underlying question here is, why are users not in demand? Clearly they are an important factor in creating value in the solution. So why are they actually not in demand? Why models and not users? So the way I look at this is through the lens of a value chain. So if you imagine purchasing this software from the perspective of the customer, you could say something like this. Well, so if I'm a bank and I want to do AI, the first thing I do is I create an AI model project and a team. So I say, well, you're the head of the AI team. Here's a budget. Go give me some AI models. Then the team gathers data and trains model, builds business cases. The models are then deployed and hopefully they work. So they process credit scores or does something else. Perfect. Good AI project. What we need to understand in this value chain is that it has an input end and an output end. One is investment and the other end is return on that investment. And we get, if we support this value chain with our software, we get to attach our pricing to any given step. So if we attach it to the first, it's users. To the second, it might be gigabytes processed or data entries or something like that. It could be models in production, or data outputs. The further we are to the end, to the output end, the more demand the customer will have for it. The further we are to the beginning of the value chain, the more the customer will look at what we're charging them as a cost. It's an investment. Maybe it's necessary, but it's still not something that I'd like. I'd like to have as little input and as much output as possible. So if we look at it sort of structurally, we can say that startup chain is generally quite generic. So you can charge for users on almost any software. And I've seen users charged on almost any software, especially ones where it shouldn't be charged. It's usually also cost-focused or perceived as cost-focused by the customers. Over at the end of the chain, you now get the ability to work more into specific single verticals. So if you remember the AI model with banks and insurance companies, one of the reasons we distinguished between that fence was that, well, we have specific pricing metrics that we get to use in insurance companies, price per claim specifically, that we can't use in banks, but would make a lot of sense in the insurance companies. So let's do that there. Also, usually they are seen as more value-focused, output-focused by the customer. So I usually say that the key takeaway for pricing metrics is to understand this placement in the value chain and understand that value chains are like rainbows. The gold is at the end.